Hello. So in this lecture, we are going to understand about operational transformation. Okay. So till now, what we have seen that while there are multi-leaders and they are syncing among themselves. Okay, because they are having replications. What happens that let's say in this DB there is a client who is saying the number of emails who likes me is 2, and this is another guy who is saying number of emails who likes me is 3. Okay, but when they combine, okay, so either 2 can be there or 3 can be there, so they are writing at the same time. Okay, so let's say if we are using timestamp and this guy wins, okay, I mean he made the changes later. So what happens that this write will stay, this write will go. Okay, so timestamp is not a very good solution. Second, what we have seen is version vector. Okay, so in version vector, what was happening that initially number of females that like me is 0. Okay, so this basically denotes changes in this DB, and this basically denotes changes in this DB. Okay, this array, and both of them have 0 0 array. So when this guy told that number of females who likes me is 2, so this became 2 comma 0, and when this guy said that number of females who likes me is 3, it became 0 comma 3. Okay, when they resynced, okay, so this became 2 comma 3, this also became 2 comma 3, so the final answer is 2 plus 3 equals to 5. Okay, so what is operational transformation? What we do that in operational CRDT, that we have is we don't send the whole vector, because sending the whole vector can actually drain your network bandwidth. Okay, what we do, we only send this one. So it's like increment. So let me just delete it. So increment okay for L1 by 2. Okay, and this guy will send increment for L2 by 3. Okay, then they will go in some central database. Okay, they will go some in central database and some processing will happen, and what will happen finally, that we will get 5. Okay, so we only send the operation. If someone is decreasing, we can have decrement. Okay, decrement. Okay, so operations are sent. Okay, so first problem what we see with this is like there is a centralized server who is processing all this thing and then replicate, like sending the final answer, right? So what if the central server goes down? Then who will do the like calculation? Because in operational transformation, as you are only sending the operation if there are like more than one databases, okay, and they are there is a centralized server in between. Okay, so if they are like connected amongst each other, what problem may happen, that they may do some random things and which can create a lot of problems. So that's why what happened, like they send to a centralized server and it processes and then sends the final results to everyone. Okay, so first problem is what if this centralized server goes down? Okay, and the second problem is like let's say there is a database. Okay, there is also a database. Okay, and we say add Akash. Okay, at time t1. Now this gets replicated to this DB at time t3. Okay, but at time t2 I say delete Akash. Okay, AK whatever. Okay, so sorry, this gets replicated at time t4. Okay, but this delete Akash operation got replicated at time t3. So what happened? So what happened? Let me just revise again. At time t1 we say add Akash. Okay, at time t2 we say delete Akash. At time t3 the delete operation gets replicated. At time t4 the add operation will get replicated. But as we are only replicating time t3, like delete operation at time t3, what happens that it sees that, oh, I don't have Akash. I don't have Akash, right? So how can I delete it? I can't delete it. Okay. So therefore it will say error. Okay. And after that, we send Akash, add Akash. So Akash stays here. So in DB1, Akash is deleted. There is no entry of Akash. In DB2, actually, there is entry of Akash. Actually, the first con which I told, that we need a centralized server for if like there are multiple DBs. This is the reason. This is the reason. Because if there is delay in like if there is delay in sync, this kind of problem may happen. So what happens, this guy centralize all the data and then sends the replication, final replication data to everyone. Okay, so this is the reason. Can I give you one example? Yes. So this operational transform is basically used by Google Docs. Let me just rotate it and make a diagram, then tell you. Okay, so let's see this example. Okay, let me zoom it a little bit. Okay, so let's say there are two servers or two database. Okay, so in both of the database initially there was hello. So let's say this database is A, okay, and this database is B. I don't know, like this database is A, this one is B, okay, and hello is written in both of them, and the indexes are somewhat like H is in 0A, E is in 1A, L is in 2A, O is in 3A. Okay. Similarly here 0A, 1A, 2A, 3A. Okay. Now at time T2, both of them got written. So what happened that in this step, what we are doing, we are inserting one more L in between whose ID is 4A. Okay. So we are inserting 4A after 2A. Okay, remember 4A after 2A. Okay, so what it become HELLO. At the same time, we are writing four exclamation mark. So HELO and then exclamation mark at 4B. So this right is 4B. Okay, so we are writing 4B after 3A. Remember 4B after 3A. Okay, now they started syncing with each other. Okay, so this is like they are syncing with each other. Okay, so what happened that in this, what we are seeing, like insert, okay, insert 4A after 2A. Okay, and this guy is saying insert 4B after 3A. Okay, so what is happening? Inserting 4A after 2A. Okay, here, sorry, inserting 4A after 2A, and here we are inserting 4B after 3A. So both of them become HELLO and HELLO. So like this was very easy example, but what happens if we are inserting in between? Okay, so let's see. So this is the example. So I'm not using that slate because the area was little bit small. Okay, so this is the example, like when we are inserting in same place. So basically, let me show you what happens if like two elements are added in between Google Docs. Okay, so my slate was becoming small, that's why I'm showing it over here. Okay, so previously this is server A, okay, and this is server B. Okay, now previously there were A, B, C in both of the servers. Okay, and this is like 1A, 2A, 3A, and here is also 1A, 2A, 3A. Okay, then what we do, we added 4A after 1A. Okay, so we added 4A after 1A whose value is X. Okay, and similarly here also we added 4B after 1A whose value is P. Okay, whose value is P. Cool. Sync didn't started yet. Okay, but what we did, we after that in the server A we said that we are adding 5A after 4A whose value is Y. Okay, we are adding 5A after 4A whose value is Y. Similarly here we are adding 5B after 4B whose value is Q. We are adding 5B after 4B whose value is Q. So before starting the operation transformation in the central server, we have this rule. Okay, skip over any existing list element which has a greater ID. Okay, so if like 4b is coming and it sees that the next element has a greater ID, it will skip. Okay, so let's see with example what happens when like this p is coming to this p, like 4b is uh, coming to server number A. So previously server number A looks something like this. Okay, looks something like this. 4b is coming whose value is p. Okay, so now we see, is 4b greater than 4a, which is true. So if it is true, then we are not skipping. Okay, we are not skipping. So in server number A, what becomes? It becomes A P X Y B C, where this is 1A. Okay, this is 4B, this is 4A, this is 5A, this is 2A, and this is 3A. Okay, then what happens, that this Q comes to server number A. If Q comes to server number A, so this will be the initial state. Okay, this will be the initial state. So let me just draw it again. So it becomes A, P, X, Y, what was that? B, C. Okay, this was 1A, this was 4B, this was I think 4A, this was 5A, this is 2A, this is 3A. Okay, so what comes? 5B, whose value is Q, whose value is Q. Okay, so we know 5B should be added after 4B, right? So it comes after 4B, it sees 4A. So is 5B greater than 4A? Yes, 5B is greater than 4A. So what happens? The Q gets edited over here. Okay, so what is the final list in server A? A, P, Q, X, Y, B, C. And this is 1A, 4B, 5B, 4A, 5A. Is this video? 5A, and this become 1. Sorry, this becomes 2A. This becomes 3A. Okay, so this is how server A got synced. Okay, now let's see for what is happening in server B. Okay, so in server B, at this particular moment, the state is A, P, Q, B, C, where this was 1A, this was 4B, this was 5B, this was 2A, this was 3A. Correct? From here, server 1, what is coming? From server 1, basically X is coming. X is coming, which is basically 4A. So we had this rule, right? Skip over any existing element with greater ID. Okay, so the rule with 4A was that 4A should be after 1A. It went after 1A. Now it sees, is 4A greater than 4B, which is no. So this got skipped. So now X came here. Then it sees, like, is 4A greater than 5B? No. So X comes over here. Okay, once X come over here, it gets added over here. Okay, so now the state becomes A, P, Q, X, B, C. Okay, so A, P, Q, X, B, C, where this is 1A, this is 4B, this is 5B, this is 4A, this is 1, no, this is 2A, this was 3A. Correct? Now after that, what we did, we added Y. So we added 5A, whose value is Y, and the rule was 5a should be added after 4a. So when 5a came after 4a, okay, so we can actually directly merge it here, okay, because it should come after 4a and there is no conflict over here. Sorry, yeah. So what I was saying, that we can directly merge it over here because there is no conflicts basically, okay, and after that there is no conflict, okay. But let's say we are directly not merging, okay. So what happens, like we see, like is 4b, I mean sorry, 4a greater than 4b? No. So what we are doing, that y comes over here, then we see like is 4a greater than 5b? No. Then it comes over here, then the rule hits basically, due to which what happens, that 4a like 5b comes after 4a, so it goes after x, okay. So final answer becomes a p q x y b c. So see, in server A also a q p x y b c was there. In server B also we are getting a p q x y b c. So basically what we see, after this operational transform, what is happening is that both the server, like both the viewers will get the same result, which is apqxybc, right? So this is the example what basically Google Docs actually use. This is operational transform. In the next one we will see what is CRDT. So basically this has two cons, like I told. CRDT will fix those two cons. Okay, thank you.